And there's also a trade-off. Yeah. So for some customers, that's because
It's okay. No. I don't hear it. I need this. Hello. Hi guys. I do apologize for the late. Next time when we had the IETF meeting, we should make sure we have enough elevators. Yeah, we're almost going to have a working group meeting in the elevator. All right, we are already late, so let's start. This is the Anima working group meeting for autonomic networking integrated model and approach. For this week, we have 2 sessions. We actually apply for 2 hours for both sessions, but we only get 1.5 hours plus 2 hours. So this meeting, we have the priority for the milestone work items. If we don't, get enough discussing, those work items has a priority, so they can use more time we allocated. So if necessary, and we have another session for the Friday morning. Okay. This is a note wheel. Everybody should go through it, but I guess you guys already go through it so many times. Okay. Oh, blue sheet. Yeah. We also need volunteers for JavaScript. Anybody volunteer for that? Lauren, are you on the Jabber? Okay, thank you. Minutes taker. Bean, could it be minutes taker? Thank you. We have the remote participation. Yeah. Actually, my co-chair, Teres, here is also participates remotely. And I guess that's middle light for him. And Brian Carpenter, okay. We already applied the slides on website, but it seems for the new tools, new proceeding tools, on the main material web page, we had some issues to, display our material for second session. So, you can access to the through the session page and get the material for the second session. We had the ongoing discussion on mailing list Anima, and this working group is chaired by me. Teres is accessed remotely. This is the meeting agenda. We had for all milestone work items today, the generic signal grasp and the bootstrap, also the ACP control, and 35 minutes for reference module. If necessary, they can use more time than our allocated time. And on Friday, we have information distribution and guidance for autonomic service agent, autonomic slice networking, also autonomic intent. Any bash agenda? Agenda bash? 1, 2, go. This is a written list. That's also a list our working group document. For short brief, we had the generic signaling grasp documents already passed the working group last call, just before this meeting, and the authors has done an update according to the working group last call comments. They will report that today. Hopefully, we are in very good shape to send that to IESG after this. So I'm the Sheffield, document Sheffield. Bootstrapping is very close, but it seems there are some ongoing discussion recently. We'll go how the discussion goes today. And the autonomic control plan is pretty stable. After this meeting, we plan to launch the working group last call. Yeah. And the two validation case, stable connectivity, prefix management are both stable, but we are waiting for the grasp and ACP documents goes first. And the reference model is keep going. Hopefully we will hand it ready before next meeting. Okay, that's the working group document status. Our first speaker, Bin.
Good morning, everyone. My name is Bin Liu to present the latest update of the graph signaling protocol. It's the 08 version, and in last IETF, it was the 06, so we have two updates. The first one, the 07, and we launched a working group last call for 07. And after that, we got some very valuable comments, especially from Michael Richardson, with thanks a lot. And then we have another update, 08, based on the last call comments. Okay, for the 07, there are several changes. The first one is we add TTL to the flood message. This is to limit the hops that a flood message can travel around the domain. And we also added locator both in flood and discover response message so that the receiving node can identify the source of the message. And we also added some description of limited security graph instances. In detail, we have 3 limited security graph instances. The first one is, in some cases, the graphs need to run between domains with a mutual agreement of the domain's administrators. So this is an uncommon usage of grasp. So these instances should be totally isolated with the normal grasp within one domain. And the second one is we have a nickname called DAO, Discovery Unsolicited Link Local. This is specifically for at the very beginning, before the bootstrapping process, there's no security guarantee. So we limit the grasp within the link local scope. So this is that we call DAO instance. And the third one is we also have a nickname called SONN. It's sorry, I forgot the full name, but it's for the ACP negotiation. Before the ACP established, the nodes, especially the neighbor nodes, they need to negotiate with each other. And at that time, there's no ACP protection for the graph messages. So, but we do have security keys at that stage. So we use the keys to establish a TLS transport to secure the grasp. And this instance also need to be isolated from the normal grasp instance. So we add a subclause to describe the 3 security limited instances. And there are also some clarifications and editorial changes. Okay, so in the 08, we added a invalid message. This is proposed by Michael Richardson. Because the grasp can be extended by various kinds of options. So if a older ASA doesn't recognize a newer option, so he can just reply an invalid message to indicate he cannot understand the content. And it is better than just ignoring the messages silently. And we also increased the session ID from 24 bits to 33 bits. The one reason is to reduce the opportunities for session ID collision. The other concern is because in CBOR definition, there's 1 byte, 2 byte, and 4 bytes. So it's very natural to use a 4 byte, which is 32 bits. And we also added more rules to avoid the collision of the session ID, mostly regarding to check the existing ID. The node has been used, and also in the cached session IDs. And there's some correction of the description of the port used for the discovery response message. And there are some special cases that the discovery is communicated through unicast message rather than the normal multicast. For example, one node has a cache of the negotiate counterpart, and after some time, it want to re-establish some connection with the counterpart, then you can directly use unicast discovery for that specific node. And we also specified default maximum message size, which, if I recall correctly, it was 2 megabyte. Next, please. Okay. And we also make some correction of the description regarding to the timeout for the request message. And also improve the wording on exponential backup for the DDoS attack, because the discovery is on multicast. So there's the threat that malicious node can rapidly send many discovery packets to cause the denial of service for the responders. So if the rapid goes up to a certain level, the receiving node need to apply its exponential backup, which is to reduce the response packets significantly. And we also clarify the relaying, discovery relaying is not done in the limited security instances because this is for more security considerations. At these limited instances, either in the DAO instance or in the SONN, is only within the link local scope. The node won't forward to another link. And we add some example messages in the appendix, and also some explanatory text and editorial improvements. Okay, Brian Carpenter, our co-author, is always maintaining the Python prototype. So the prototype is, along with the draft process, is being updated to consistent with the newest version. And it is available for both Windows 7 and Linux. And Brian also implemented two toys ASAs to negotiate together. And if I recall correctly, one is in Brian's home, the other is in his workplace. And also includes some model used for the bootstrapping negotiation. So we encourage you to play with the code, and this is the link. And as far as we know, we currently has no additional technical issues. There's one minor concern that we use the CDDL to describe the CBOL encoding, and we make it as a normative reference. But currently, the CDDL draft itself is not normative. But as Carsten pointed out, Carsten, who is the author of the CBOL and the CDDL, the CBOL is now under a working group forming. So this grasp draft can actually help the CDDL to become a normative reference. Okay, next, please. Okay, so for the next step, the authors believe it is now ready for IESG. And there's also an ongoing Grasp API work. So while this, if the 0.8 version is stable, we can update the API based on the 0.8 version. And we have another prototype. Actually, is earlier than Brian's Python code. It's coded in C++, and we have it in the GitHub. And we also plan to update the codes when the 8.08 version is stable. Okay. Any comments?
One question being, did you ever do the interoperation test between two prototypes?
Not yet.
You should do so.
Yeah.
Okay.
So,
that will help a lot to see whether it's interoperation issues and whether we, should state such issue or fix issues in the draft. Yeah.
Sure.
Okay. This document already passed the working group last call. We're still thinking for more reviews. So if you have interest in, please do review and set the comments to the mailing list. We are planning to send this document to ISG in a month's time. So any comments before that, we could, address that into the latest update and be better shape for the ISG review. Okay. Any more comments? All right. Thanks, Bing.
Thanks.
So next, Bootstrap should be.
Hi, I was wide awake until 5 minutes ago. Hi, Michael Richardson, and Max is on the Meet Echo, which he may chime in. He has pointed to one correction I need to make. So I'm going to just very quickly recap what Brewski is and some of the things the design team has gone through in the last since the last IETF. And I have Kent Watson in the audience there, who is going to say a little bit more about how the ownership vouchers work, because that's one of the points of cross coordination between the working groups. Okay, next slide, please. So what does it look like? Essentially what we're trying to do is we're trying to enroll a new node into our domain such that it can have ultimately a locally relevant certificate that allows it to bring up an ACP connection and join an autonomic mesh. This is facilitated by a bunch of different components, and I've illustrated them here. The brown ones, they are unfortunately hard to see, and I have another slide with it in different colors, which you'll see on Thursday in another working group, are the nodes that are already a member of the net, of the autonomic network. At the top, you see a registrar with a big orange arrow pointing at it. And the idea is that we're going to enable connectivity from this red node M at the bottom, specifically for the purposes of running RFC 7030, which is enrollment over secure transport. And then the question is, what is the secure transport going to look like? How are we going to get it there? And this kind of stuff. On the upper right, we have a manufacturer. Go to the next slide, please, already, because I have a, no, go back, I'm sorry. I have, this is, go back. Yeah, we have a manufacturer. The manufacturer installed a certificate, a manufacturer installed certificate. That's often called a MIC. That's often confusing to crypto people because that often has a different acronym expansion for that. Manufacturer installed certificate, and the registrar received through a MASA, which is not in this diagram, an ownership voucher or an audit token, which is proof to the node M that it belongs to the Brown network. Now, next slide, please. So we had a long discussion about the direction of those orange arrows. And the reason is because different people, different areas want to do things in different directions. So I'm going to start by discussing what the NetConf people did. And they have a draft called Call Home. And NetConf is a little bit different because it's not really about an autonomic network so much. It's about configuring devices that are out there and who are joining a network that's pre-existing. And there are NATs and V6 is not assumed. So what they actually have is they have the new node, which I call pledge here, and we sometimes call join node or new node. They have it do an outgoing TCP, the same as, you know, the web works, right? And as soon as that TCP connection is made, they change the roles of the two ends. So the machine that received the connection becomes the client from then on, and the machine that made the connection becomes the server. So if you're doing TLS, for instance, that means as soon as the connection is made, the server or the responding machine does a TLS client hello, and TLS and HTTP or whatever all proceed the other way. So that is the registrar acts as a HTTP client to the new node. Okay, and they also work that they have a different way. They do it with SSH instead of HTTP. So that's called the call home mechanism. We just discussed strongly whether or not we should adopt that mechanism because we thought, well, you know what, let's be the same. And there's some other notions that we could do. So specifically, we have an incoming mechanism. We say, well, you know what, we don't actually need to do the outgoing TCP and then turn it around. Let's just do an incoming TCP. So that is, the registrar will simply reach out to the new node and connect to it. And you say, well, how can the registrar find the new node? And the answer is, well, because we have this assistant that allows it to statelessly pass traffic to the new node using linked local addresses. Finally, we have the simplest thing, which is you reach out from the new node to the registrar, you initiate, and then the new node essentially is the client to the process. And that's what EST assumes. And after a lot of discussion, we decided to stick with that. I'm just going to tell you why we were considering changing. One of the reasons we were considering changing is that EST essentially runs over TLS. One of the things you do in TLS is, you know, the client, first of all, the client potentially sends its certificates, and then, excuse me, I said that wrong. The client says hello, the server says hello, and the server sends its certificates, and then possibly the client sends its certificates. So the important thing is that the responding machine sends a certificate first. And the interesting part about that is that while the new node has only a single certificate and it can only send one thing, the registrar could potentially send a variety of different certificates if it knew who it was talking to. So the example is here, you have an ownership token or voucher, and that is in fact a certificate. If that you do that model, then if only the registrar knew what device was attempting to connect to it, then it could respond with a certificate that actually said, yes, I am your owner. And so that was the nice thing, because the TLS numbers, that orientation works well, and you do things. One of the reasons we decided not to do that is that it means that the new node has a TCP port open which you can connect using TLS, and you can say, hey, who are you? So you have a new node sitting out there, you know, in the wild, and anyone can walk up to it and ask who its identity is. We decided this was pretty undesirable from a privacy point of view. We didn't want to do that. It doesn't happen in the call home scenario, because in the call home scenario, the new node initiates to the network. It doesn't have an open TCP port. Okay, so it doesn't. You can't just walk up to it and say, hello, tell me who you are, right? It has to go out and tell people. So after, I think, what, Kent, I think 6 weeks of discussion, okay, weekly calls, we decided to stick with what we started with, but we really considered it very strongly as what to do. Next slide, please. So I said something wrong, which I was supposed to fix this morning and did not. The audit token may not be a bearer token. I said that wrong. There is possibilities of having a bearer token, but it's not in the audit token. It's in the ownership voucher. So one of the commonalities across 6 tishes, zero touch join, Anima's bootstrapping, and netconf is that we're all using the same essential statement of ownership. So the key thing here is when you have a device. How many of you connected to the Wi-Fi this morning? I'm sure all your hands should go up. Okay, and you clicked on the little thing and it said IETF legacy, and you made a decision. You, the human, made a decision as to which network you would join. Okay, and that's the thing that's missing from IoT devices or autonomic devices, is that those devices have to somehow figure out which network they are going to join. To do that, essentially, they're making a decision, essentially, where they're going to, who they belong to. And to do that, what we're doing is we're essentially saying, hey, there will be a certificate that the network will prevent, or excuse me, a signed artifact that the network will present that says, you, device XYZ123, belong to network IETF legacy, or whatever, okay? And that's the thing that we're trying to do, and we're trying to make sure it's common across all of the things. So an audit token has a weak link to the owner. It may or may not have the DN of the owner, and it may have the hash, the public key of the owner. But in particular, it doesn't always say which network the device should join. Rather, what it says is to the device, if you join network XYZ, a record will be made that you join network XYZ. And that matters because if you do it that way, if the device later is going to join another network, someone else can say, oh, but you were supposed to have joined that network. I don't trust you anymore. Okay? So it becomes a bit of a first, it's almost join the first network you see, but it's the first network you see that can produce a credential that says, or an artifact that says, I will record who you are and I will keep you safe. The ownership voucher is a little bit stronger. It very, very much says, this is the network for you, and I know you by your number. So next slide, please. So we had some interesting token requirements here. It's very important that for many uses that we're able to do this online. So there may not be an ownership voucher or an audit token that is, I'll come to you in just a moment. There may not be one created when the device is created. You may have to go and get it. It might come through a sales channel. You may get something else that you're going to go back and contact the manufacturer, and they're going to create one in real time. At the same time, people have their opposite requirement, which is that they have to be able to take the device and put it in a warehouse for 20 years. And at the end of that period of time, they know they have something that will let them activate it. So there's some contradictory requirements. So good time for your question.
Dan Bogdanovic. So your example with the network selection, and that the network is making some of decisions for myself is the one part that I dislike. And I wanted to ask you, do you have some other use cases for for this? Because I want to have the ability to have choices that I can influence, and then based on my choices or my desires, the network will provide me, the connectivity that I need. Because
I'd like to come back to your
so for
question.
I would like to say, look, I want to connect to the network with a low latency and with, let's say, this set of services.
Mm-hmm. That is a reasonable thing to ask for, and you're a step ahead of this. Okay, and the reason I'm saying that is because I don't know who you are. You said I would like to do this.
Mm-hmm.
In an autonomic network, you may have some desires, but I don't know who you are at this point. So you're making the assumption that you can express your needs, saying I want to connect, and I'm telling you at this point, the network, I don't even know who you are. So I can't satisfy your needs because I don't even know who you are at this point. So you're the step after me. After we agree on your identity,
mm-hmm.
then you could express the desire, device XYZ, and I agree that your device XYZ would like a low latency connection. And I could say, oh yes, it says in my properties that devices of type X get low latency connections. I'll offer you one. But at this point, the point where we're operating, I don't know if you're device X or, if you're some other thing elsewhere.
Okay.
Okay. So that's why I'm saying you're ahead of the game as where we want to be.
Okay.
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 That makes sense to you?
Yeah, makes sense. Thank you.
Yeah.
Okay.
Yeah, I believe that's out of the scope for the current document, but that could be something we're working on later.
Exactly. That's the point, is that after we have the autonomic network, then we can start discussing, well, what is your not autonomic connection going to be?
Yeah.
Okay. So
I assume that that kind of network selection also needs to be autonomic.
yes, sure. But I think that's an ASA that is a subsequent ASA that you do afterwards, where you say, and I wish to have non-ACP connectivity to this thing, right?
Yeah, just a word. For this working group, we did charter to work on the autonomic network infrastructure for the current charter. That means the ASA we just discussed may be out of scope, but we are considered to, for the next charter, we may, also include some, important ASA to make this autonomic more wider use. So that could be some potential work. So I encourage you guys to, work on that and bring that as potential future work items.
Yeah.
Yes. Hi, Dan Bogdanovich. So one thing what you said is with the authentication, but you already connected me to a network, and I don't know if the network to whom that can satisfy my service requirements. So based on my desire, based on my intent, what I want to do, you can provisionally connect me and then authenticate me, and making sure that you can, because you can connect me to a network that cannot satisfy my service requirements.
So to be clear, okay, assuming that I am your mother, okay, and this is it goes back to the ducklings.
So you know what's the best for me.
So assuming no, but once we've figured out that we have a parent-child relationship, okay.
But let's say I'm a teenager.
You're now a teenager, yes.
Yeah.
Okay. So, but first of all, you have to be a child.
True.
Okay. And at that point, we have connectivity to you. And if you have some additional requirements, it may be that through some other management protocol, I'm going to say, you know what? You didn't connect to the right network. You need to connect to this other network. But that other network's already going to trust you. Or you need to connect on this other interface, this other ESSID, this other port that you have, this other thing like this.
So you're then doing it sort of like, this is my first network to whom I'm getting the authentication, and I can roam into other networks, but then keeping my authentication from the original entry point.
You now have a credential that my family will trust, right? If I'm going to send you down the road to your uncle's house for your connectivity that you need, uncle will understand it's really you. It's not somebody else.
Okay, have to think about it, but
okay.
Yeah. Okay.
So one of the things that we've heard regularly is just want to go back to the vouchers, is how you get them, is that many supply chains are not going to be mature enough to actually provide things like ownership vouchers through their supply chain. So the example is, 1,000 light bulbs go to some distributor, who then goes to one of Amazon's warehouse, that goes to some place that goes to you. And through that process, somehow you need to actually get an ownership voucher through that supply chain. Those supply chains may not really work. So there's a couple of different things that might happen. For instance, you might find a bearer token in a form of a QR code inside the package. Okay, that's one way. And for a light bulb, that may be entirely appropriate. Is that appropriate for a $5,000 sensor that you put on that controls your house alarm system? Maybe not. Maybe that QR code lets you talk to the manufacturer directly and claim ownership, and then you get something. And now it's actually your warranty exchange, and you did it on a website, and then it was installed. Okay. How that happens is a little bit out of scope, but the point is that we want to make sure that we've supported it, and we haven't essentially said, after these 12 magic things happen in the business world, our technology will work. And we've seen how that's happened for secure email and stuff like that, and we're all sending SMIME today. That's not work because of that. So we have to make sure that we have outs so that we can get to the credentials we need without necessarily depending upon the supply chains to mature as quickly as we like. On the other hand, we really do want to support supply chains that do want to do that. So that's there. And finally, there is an open question, an open issue, which we've discussed and we're trying to support, but we really don't have a good answer, which is what happens if you resell a device. Okay, so it may be entirely reasonable that since you buy your Tesla car directly from Tesla, that they're going to quite easily provide you with the right certificate for you to claim ownership. They may be quite uncomfortable with you selling that car to your friend and transferring the ownership. I don't know, okay? And since they have a manufacturer installed certificate, they may be able to prevent you from that resale. And that's something that, you know, we may want to support and we may want to be neutral on, but we need to be able to basically clearly articulate this device is resellable. This device is resellable by you doing a transitive certificate. This device is resellable only when the manufacturer agrees that you're going to resell it, right? And so those are issues that we kind of have to address because we're talking about essentially a very strong statement, digitally signed statement of ownership. Okay. Next slide, please. Is there one?
No?
Yeah.
No.
No, that was it. So I had
That's
one.
the last slides.
Yeah, I know we had one more slide, but I know you didn't get it yet. So, Kent, do you want to speak for a moment about some of the other differences between audit tokens and some of what's happening with the vouchers at your end?
Sure. Kent Watson, Juniper Networks, and I've been working with the Bootstrap design team for the last 4 months or so. And it's kind of hard to go into great detail right now with just 3 minutes, but I think the main point is that there's one notion that Michael didn't mention is there's also the notion of revocation for these long-lived devices where the vouchers might live for, you know, it's not just ephemeral voucher, it's a long-lived voucher. And we want to ensure that the assertions that were made when the voucher was originally signed are still true when the voucher is processed. So this is where voucher revocation comes into play. And there is a draft actually in the NetConf working group right now that I've written, and Michael and Max and Torlis are co-authors on, that goes into this. And one of the questions actually is which working group should take up that work, this draft. I'm presenting it to the NetConf working group, and I'm asking them that question as well. But to this working group,
you can have 3 to 4 minutes to present this now, if you want.
Yeah, 3 minutes, sure. Let's just jump right into it. I'll do what I can. Next slide, please. Yeah, so the draft does touch on these two artifacts, the voucher and the voucher revocation. The voucher is used to assign the device to an owner. The revocation, just like I said, again, it only defines the artifacts themselves, leaving the distribution to bootstrapping protocols. Next slide, please. So the zero-touch draft previously stated, and again, these slides were designed for the NetConf working group. So to them, the zero-touch draft previously stated that the voucher and revocation artifacts were vendor-specific formats, but we felt that we should standardize them because they could be used by multiple bootstrapping protocols such as Brewski and M6ish. And also the development of tool chains to encode and decode them can be created. Next slide, please. Just a quick look at the voucher format. I can't go into great detail at the time allowed, but there is an assertion, so it's an enumerated value, and it could be like, when the voucher was signed, what did the massa think about it, right? Was it basically just saying that it logged the event of having signed the voucher, and so there's traceability and transparency, or did it actually have some notion of it verified the ownership, you know, through supply chains and sales channels? The trusted CA certificate is what Anima refers to as the domain certificate. The certificate ID is something that's not used by Anima. The unique ID, you see a little asterisk that stands for multiplicity. For Anima, it's really just a singularity, right? It's the vouchers to a single device. But in NetConf world, it's possible the voucher could be applied to multiple devices. A single voucher could. You see the nonce, which has been discussed before. Created on is really just for debugging purposes. Expiration is, again, for long-lived vouchers, and it's questionable if it will be used in Anima. It does, of course, bring the concept of time and reliable clocks and security around them. Okay, next slide, please. A quick view on the revocation. Again, there's a revocation type, And here, there's like issuer-wide versus voucher-specific. So issuer-wide is a little bit like a CRL, right? So the issuer has a big list of all the devices that either revokes or doesn't revoke. So a notion of a whitelist or a blacklist. And or voucher-specific is a little bit like OCSP response. Next slide. A quick view into the issuer-wide and voucher-specific. I don't want to go into detail on this slide. Next slide, please. Okay, so there's a question of encoding. I think this slide is mostly for the NetConf working group, so we can skip over it. Signing strategy. So both these artifacts must be signed, but as yet, the signing strategy has not been selected yet. Some options that have been discussed is PKCS7, CMS, and JWS, but we'll pick one shortly. Sorry, just a second. Yeah. All right, next slide. Okay, this is for the NetConf working group. Okay, that was it. Again, the main thing I think is which working group should take up the work of this particular draft.
If it wasn't happening in NetConf, we'd have to do it here, and if it wasn't happening here, they'd have to do it in NetConf. So someone's got to do it.
And we both have the same AD, so.
We don't have time for discussing because that's non-work item, mild work item. So I would like to get back to not go. Yeah, we haven't finished for Bootstrap yet. Yeah, I would like to get back to the Bootstrap document. Yeah, because for now it seems you are talking about a lot of scenario and the considerations, but I would like to focus on what's going on for the current document.
All right. So go ahead.
My question is to you, Michael, about the Bootstrap document.
Yeah, go ahead.
There are two things that can come back: an ownership voucher or an audit token. I am not clear whether we now make it hard-coded for a pledge to say I will only accept one or the other, or do we accept either?
I think you wrote that on the list, which is that specific devices it's decided by the manufacturer how they're going to be operated, and that so the device is going to expect one or the other, that it's perfectly capable of expressing that through EST, and that the masses it will know what kind of device it has, and if it doesn't know, then it doesn't know who that device is, right?
So do we allow this to happen, or is that a requirement? Is that a vendor can do it that way, or does it have to be that way? I'm a little bit uncertain about this now.
I don't understand the question.
The way you respond is a vendor can program his device such that it does require one or the other.
The vendor has to pick one or the other.
The vendor has to pick
the vendor of the device picks one or the other. The massa has to basically, and the registrar have to accommodate the kinds of devices they're going to enroll.
So it
Right.
So that's must in IETF language.
Must essentially the registrar must accept either. It's entirely possible. I mean, for a specific device, it will accept A or B, but it must support method A and method B. And maybe all the light bulbs are audit token based, and all the routers are ownership voucher based. But the registrar is common to both.
My question is more about the pledge. So it is not a valid scenario that the pledge may accept one or the other. It must accept either or.
The pledge must request A or request B. The pledge is in control of the process.
Thank you.
Can it
Okay.
do both?
Pardon me?
Can it do both? You should A.
Well, he
or
can't.
B.
I don't think he can express both. I don't think he can.
No,
I don't think he has a negotiation.
Must be either or. But my point is it has to be enforced on the pledge.
The pledge says, "I want something that looks like X," and he validates it looks like X, and that's what I would. Yeah.
With regards to in which working group to make this, I believe that Anima is the better working group because of the overall context. The if you put it into the netconf working group, you might lose the context and be more focused on the protocol specifics. And here you really want to be more focused how you, and see if there is need to put, what exact extension would be needed, and then maybe just put it back into, if you have to extend one of the netconf protocols, or one of the netconf RFCs that you have to extend it, then just send it back as a requirement, to the other.
I don't think we'll have to touch them. It might be that netconf will standardize on a different expression of the Yang.
Yeah.
I hope that doesn't happen actually, but that's a possibility. I really hope I hope we actually make that decision clearly and we pick something.
Just to add to that, and it doesn't impact the netconf or restconf protocol. It's really the vouchers are just being brokered as payloads.
Yeah, it's payload. So
Inside
that's the reason I'm saying it would be better to do it here than in the netconf group.
Yeah, and netconf supports putting these things on USB keys, for instance, right? But we don't, right? It's not we're not doing that.
Yeah. In that case, I encourage you, to, bring it back next meeting and apply the time slot earlier. Then we can, have a proper discussing on it and, consider that for, in the charter. Yeah.
I think that so you're suggesting this work is out of charter. I think that I'm not sure I understand that. I think that what we wound up doing is we wound up basically saying we have a bunch of text which is going to be in common with another group. If the netconf group didn't exist, then all of Kent's work would be inside of the Brewski document already.
Mhm.
Okay, and so would in some sense be in charter already. So the discussion is, okay, well, look, we realize this is refactorable across 3 working groups, and so we would like to not do it 3 times.
Sure.
Okay.
Yeah.
And so we would like it to be common, and so the question is now about ownership, not about. I could say it's in charter for all 3 groups at this point.
And also, I think there's a question of timing. You just mentioned bring it back next meeting, and we might be looking to go to last call. I mean, in terms of speed.
All right.
I think the design team will even, will resolve the question of format with the working group's feedback, of course. We very much want that feedback. But the issues that we're having in this document, I think we'll resolve within the next, 3 to 5 weeks kind of thing.
Okay.
That's our goal, to do that. And so if you, hate PKCS7 or hate JWS or JWT, I think you should say so.
Okay. Any other issues for the bootstrap document?
No, as I said, we spent a long time on that issue with the pretty colors. But in the end, we decided quite firmly to stick with what we started with, even though there were some good reasons to go elsewhere. And I think that's the major message from the working group, is that, the things that we've been struggling with, and I think have resolved.
Okay. Then I do have one. Okay.
Ooh,
Oops.
we have a blue.
Terrace, you're on.
Yeah, so maybe just something from being part of the Bootstrap design team and working group there. I think through the work of the Bootstrap design team, it became clear that there are these, complementary ideas about the Bootstrap from Max and Kent about the model on how to authenticate, and that ended up being the voucher stuff. And I think the outcome of that will be good and useful. It just, is probably also a factor of that has caused, a little bit more delay than we would have liked to see in Anima. And so I think we should take that up and, explain that to our area director and look for further advice from him, if that's fine to proceed as it's currently going.
It's not here.
Okay.
I was going to say, we don't have an area director in the room, right? He might tell us what to do.
Well, if you run into him, maybe one of you folks local can explain to him.
Okay. Okay. Actually, next Oh no, next is should be Terrace. Terrace, are still there? Yeah, okay. Join the queue.
Okay, can you drive the slides, please?
Yes.
Awesome.
Your slides is on, but your image is gone. I don't
Oh,
know what's
okay.
different from last time.
Do you see
But
my?
your voice is good.
Okay.
Yeah.
So I don't see the slides. Doesn't matter. I'll tell you which slide number to use. Okay. So this is a quick update on the autonomic control plane. Version 04 was checked in before Seoul. Slide number 2. So we haven't done as much progress as we wanted to due to some issues on the author side. We'll pick up the pace after 97. So the main improvement that was done in 04 is reworking the text about the discovery protocol. And I wanted to just quickly summarize that part because it really relates a lot to what was done in Brusky. In 03, which we presented in Berlin, we assumed and suggested MDNS for the insecure ACP neighbor discovery, the first step when the ACP is being set up. Because the Brusky design team had at that point in time already preferred MDNS over GRASP for Brusky itself. And so the simple thought was that a common protocol for Brusky and ACP sounded prudent. So that was the 03 rationale. And of course, in 03, GRASP was used for the TLS secured ACP channel negotiation, and then inside the ACP. So it's just 1 out of 3 where we were suggesting for ACP to use MDNS instead of GRASP. Now, so in 04, we added back GRASP for insecure ACP neighbor discovery because of what I wanted to talk about here. So first of all, Brian Carpenter did a great job in the GRASP 08 to define the different subsets of GRASP. And so what we're talking about here is what's called dull mode of GRASP, which is the most simple and struck down in terms of simplified subset of GRASP for the insecure discovery. And so we revisited the justifications for the preferences of GRASP in the main part of the ACP one, and then removed the appendix text about it. Slide 03, please. So technically, going back and forth on all the different arguments, I think the...
Wait, Curtis, we have a question. Bing?
Yep.
Hi, Thomas. This is Bin.
Mhm.
I noticed you mentioned DAO for the ACP discovery, but in the 08 version, actually there's another GRASP instance called SONN, which is security only neighbor negotiation. It is specifically for the ACP discovery because at that point, after the bootstrapping, the nodes all has the key infrastructure, so it can utilize the keys to initial TLS connection between the ACP for the ACP discovery. So I think that is actually secured rather than the DAO instance.
Yeah, if we go back to slide number 2, that is actually what I said A. So where basically a TLS, DTLS, we prefer TLS connection secured by the neutral credential is used to negotiate the actual ACP channel protocol. That's what SON is.
Oh yeah.
Mm-hmm.
Yeah, but I think that discovery also could be protected because it is when we discover the ACP neighbor, we don't need to multicast around the domain. We know which neighbor we want to negotiate with the ACP tunnel. So
no,
I think
that's not true because we don't know who a neighbor is, right? I mean, dull is really called dull intelligently by Brian because the only thing we're trying to do is a link local multicast to figure out what bloody neighbor there might be that we can talk to. And then we're transferring into either SON, which is basically a TLS negotiation, or even a simpler, let's directly try IPsec to that neighbor. So it's really, DUL is only about the multicast to find neighbors on the interface.
Okay. I understand. Thanks.
Sure.
Okay.
So slide number, sorry?
Yeah, we're on slide 3.
Right. So technically, my key argument for preferring GraphDAL over the alternatives really comes from thinking about the case of a layer 2 local area network with, a bunch or maybe even a large number of routers, as we know do exist in, for example, service provider broadband access environments, and then layer 2 switches between them. And if the layer 2 switches do not support the ACP, obviously what would happen is that we're building a full mesh of ACP secure channels between them, and there's nothing better we can do. But obviously, having the layer 2 switch enabled for ACP is highly desirable for the switch itself, so that it can as well be managed autonomically and be part of the autonomic domain. But equally, it would also then be able to be the one node that has ACP channels to all the routers, so that you can avoid having the full mesh. And the full mesh is really, when it comes to deployment and support in devices, I think a really highly undesirable part of the ACP, because it means that the number of crypto associations and the number of virtual interfaces that you have is unpredictable and doesn't have to scale with the hardware that you have, right? If you look at the right picture, then the number of virtual ACP interfaces, the number of crypto associations that might be hardware accelerated, only needs to scale with the number of physical interfaces. So it's very easy to make sure that any device that you're selling with ACP can scale to that amount. If you're going in a full mesh, you never know how large it is, right? So I've seen those, properties of protocols really limit their deployability in arbitrary situations. So that's basically the pitch why, layer 2 ACP switches are a good thing. And we certainly should make sure that we choose the protocols to make it most easy to support them. Slide 4. So what then are our options to make the discovery of ACP neighbors in such a layer 2 environment with switches possible? And while there are even more complicated ones, I just quickly wanted to summarize the 3 ones that obviously come to mind. The first one is CDP and LDP. That's where packets already are filtered by layer 2 switches on layer 2 ports. So that sounds ideal. Unfortunately, those CDP or LDP switches would also filter these packets on non-ACP enabled layer 2 switches. And that, of course, would stop making the ACP discovery work in the presence of such switches. So that's basically why we, high level ruled out CDP, LDP fairly early on. Now, there are solutions that work around this. So in Ethernet OEM, for example, there are, I think, 6 or 8 different MAC addresses used for different layers of LDP in Ethernet OEM. But that is actually, quite complex. And I think ultimately, trying to add that discovery to LDP would certainly result in more and not less novel and unproven code bases than DUL. So the second solution, obviously, MDNS. And this is basically where my big pain comes along, because I think we're making MDNS, we're creating a lot of pain for MDNS on the layer 2 switches if we would ask them to support ACP discovery here. So what MDNS on the layer 2 switch would need to support is to filter the MDNS packets. And I'm not aware of any MDNS implementation doing that across layer 2 ports, right? Yeah, there are layer 3 switches that are doing that across layer 3 interfaces, but LANs can really have a high number of MDNS packets, and those switches would then have to, software replicate them to all the layer 2 ports and then filter out and remove the ones for ACP discovery. And I think that would make, currently working layer 2 switches MDNS, that's just forwarding in hardware, very fragile and risky. And so that to me is the, biggest challenge. And that was kind of, for me, the most important part to say no to MDNS in that simple discovery. Now, grasp DAO, right? It's a unique layer 2 address, not used by any other functions on insecure lands. So there are no conflicts of that discovery with anything else. So it should be very easy to do. And given how minimalistic DAO is, it's also the most simple protocol to implement. You know, KISS, keep it as simple as possible, less prone to attacks than, you know, more full-fledged protocols than MDNS and CDP, LDP. So that's basically my motivation here. Let me quickly go through the other 2 slides before opening up the mic for discussions about those points. Slide 5. Now, does this thinking apply to MDNS for Brewski? I think the arguments for Brewski, what it chooses, this layer 2 argument doesn't apply to Brewski because Brewski, the proxy doesn't have to be on the layer 2 switch. Brewski will work equally well if it's just on another router in the LAN. Sure, the the new pledge will maybe see 50 routers and pick one out of them, or maybe need to try all 50 routers before it finds one that works. And maybe that is not fully ideal, but on the base of it, the layer 2 switch argument doesn't apply to it. And also, there is no need for the layer 2 switch if it wants to be pledge or proxy to change its code, because it would only run MDNS on its layer 3 interface into the LAN unchanged from what it would do today. So basically, just as a working group chair note, right, we need some rough consensus determination on the discovery for Brewski, and I think Michael will, in the reference model, maybe we'll have more discussion there. So far, we only had a rough consensus on MDNS from the Bootstrap design team. So, and just, talking about what the discussion was in the Bootstrap design team, one of the major concerns that was brought up was sharing a protocol like GRASP in an insecure context, in a secure context. And, having thought about that longer, it came to my mind that if we wanted to try to have a hard rule of trying to avoid protocols to be shared between secure and insecure context, then I think we would run into all type of problems limiting the usefulness of the ACP, because the idea of the ACP, and that's, I think also in this, deployment draft that I have laid out, is meant that a lot of protocols that already exist would be run inside the ACP, SNMP, NTP, TFTP, NetConf, SSH, right? So, and those, of course, would also be run outside the ACP. So I think it would be very hard problem trying to come up with a security rule of saying we can have each protocol implementation only on one or the other side. And from my deployment and implementation experience in routers, the single cross VRF instance of many protocols is common practice, which is not good. But if you want to solve that, it's not choosing different protocols, but it's choosing different instances, trying to have memory protection, right? So using other approaches to solve that issue. And yeah, going back to the KISS, keep it simple, I think is probably the most prudent approach to an insecure protocol. All right, that was basically what we did. Open issues. I certainly would love to start a little bit more organized, like Brian did for GRASP, a tracker of open issues. The ones top of mind, the separation of the ACP from the data plane. So that was an ask from Brian. And I hadn't put anything in there so far on the ACP side, because the VRF concept is really a long-term concept in the IETF, right? Look at layer 3 VPNs and other technologies that the IETF has built, but I'm really not clear of a good, implementation facing IETF spec for that virtual separation. Maybe, if there is somebody can point me to it, but I've always seen that to be just an implementation issues for the vendors. And I think the one new interesting aspect that, might change our approach to that and justify bringing more of that into text like ACP or so, is if we figure out good reasons to evaluate and specify the ability to build the ACP on top of, let's say, standard socket APIs, which is, for example, what for GRASP, Brian's implementation is trying to do, and which is certainly not what routers currently implement most of their VRF stuff upon, right? They all use vendor-specific internal APIs, and other context things. So building things like ACP or GRASP separated in the ACP on top of standard, Unix, Linux, Windows API is certainly an interesting aspect to look into. So that was one part. The other one was that example workout of a GRASP negotiation for secure channel options, basically that SON part and I had some thread about that, but yeah, we didn't make progress on that part. And that's it.
Michael Richardson?
Okay. Michael Richardson. So I think in discussions, going back to the MDNS question, I think that we probably can agree at this point that we probably can do everything that is autonomic only using mFlood and GRASP, and that provides everything that I think that both the ACP needs and Brewski needs with one message probably. We would like to support as a combination of may and should MDNS for bootstrapping of other things that may not join the ACP for reasons of their capabilities. But that's kind of, on a less, certainly not on a must basis. The second thing is on the topic of VRFs. While I agree with you that creation of separate routing, virtual routing fabrics is very much platform specific. Once they're created, and if we have separate virtual interfaces for the ACP, that our current v6 sockets API quite clearly lets us bind sockets to those interfaces. And so I think that's not such as big a deal as maybe your slide suggests.
I think the concepts for the set of interfaces that belong to a particular VRF does have, as far as I'm aware, no standard representation socket APIs.
I agree with you that it's not a socket API, but also the creation of the tunnels for the for the ACP to run over is also in that category. So there's a whole category of things that are very platform specific, but I believe that very much they can be encapsulated in the ACP module, and that the pieces that come out to ASAs can be essentially standard socket interfaces, just with the proviso that they need to know that only bind to interfaces called ACP or something like that.
Yeah, I agree that kind of how we built the ACP the ACP infrastructure itself might be a little bit more convoluted and less fully based on only socket standards. I think the investigation of what we can do standard or not, I think also helps us to figure out how easy it's going to be to build ASAs, some of which may need to know, okay, here I'm going to do an ACP signaling, here I'm going to do a data plane signaling. So that's, I think, what I'm most worried about, how easy that's going to be.
Yeah, I agree.
Michael Berenger. It just occurred to me, one of the main arguments here is that essentially, I'm paraphrasing, GRASP is in our control. And so we control what GRASP does. So we can decide the behavior of it. But now, if I remember correctly, Brian also wanted GRASP to be used outside Anima in a potentially completely different context. Aren't we going to run into the same issue then again, that the behavior would be different? And therefore, should we possibly have different layer 2 addresses for GRASP in Anima and GRASP in non-Anima?
And I think should we, cross that bridge? That would certainly be something to consider. I mean, Brian has already started. I hope he can chime in as well and got through his browser problems. But he's already defined these different profiles on Anima of GRASP for the different use cases. I'm not sure if for each individual use case we should have a different profile, but at this stage, I mean, these profiles at least make me very, feel very safe on the security and isolation concerns.
Hi, Torres. This is Binliu again. I have a quick complementary comment. In slides 4, you analyze several alternatives, and the graphs DAO instance is chosen for the L2 switch that not propagate the discovery message. And in the graph distribution draft, we actually have a mechanism to allow the receiving node to determine not forwarding the flood message anymore based on the content called selective flooding criteria. And so I think that also applies to the discovery message rather than only flood message. So we can discuss it in detail in the next Anima session in the distribution draft.
And we can take it
Thanks.
offline as well. Just, you know, off the top of my head, I would think that what you're talking about is something that the recipient would have to trust the sender upon. And I think in the insecure environment, you can't do it. So the way of saying on this interface, it's insecure, we're using dull. It's basically, you know, the fact that it's an insecure interface and a mode of grasp dull that gives me the security that, you know, the messages are never being forwarded. So I don't have to trust the other side.
Yeah, but for the specific DAO use case, from my understanding, there's no additional security concern because the selective criteria could be the message itself, and the L2 switch just decided by, okay, now I receive the discovery, then I just decide not to forward it to the other ports that connect to the L2 switch. So the selective criteria doesn't necessarily mean there's additional bits, additional content. And the other important part is the ASA in the L2 switch, which can determine the when to forward or when not. We can have detailed discuss. I'll add an instance in the distribution slides. Thanks.
Clarification question.
Your name?
My name is Alex Gales. This control plane is supposed to be self-managed, and there are some features which leads to this statement. However, it's obvious that there is not explicit, let's say, self-configuration, making sure that the control plane could be used in a simple or more complex, and the way to add more functionality or less. So the question is, where are these self-configuration aspects of the control plane explicit in this environment as a means to, if you want to partition the different types of control planes and use differently for in different contexts? So is it something which is part of it, embedded, or it's need to be explicit?
Well, so I was hoping that the ACP draft was answering that question. So maybe if you feel that it doesn't, then let's have a discussion on the list how we can improve the text. But just in summary, the ACP right now provides secure autonomic connectivity between the devices and the NOC, and the auto configuration would come either from SDN controllers in a non-fully autonomic network through the ACP, or through ASAs, which would have to be defined by the next round of our charter.
I think that that's a good step forward. However, it does not explicitly cover my question. And the question is that an important issue or not?
Oh yes, definitely.
If it's not important, then it should be redrafted out from text.
Look at the reference model, right? In the reference model, and maybe bring up the question and go more detailed. Michael has a lot more time on his slot. You know, from intent over ASAs into, you know, the auto configuration of devices. That's part of the reference model. That's not something that we have defined current charter items for. That would be the next round.
Okay.
Okay. Teres, I'm going to mute you because I'm wondering whether Brian he's also online, but for all the time we only allow one remote participant. So I'm thinking, Brian, is there anything you want to talk? Yes, you're on.
Well, can you, am I on?
Yeah, we can hear you. Yeah, go ahead.
This is Brian, I think I'm on. No, I think actually Tuolis expressed things very well.
Okay. Then, okay, yeah. we continue. So you actually...
I have a suggestion. So the one thing that's top of mind to me is all this discovery story. There is one slide. We could do this now. That would probably fill the rest of the slot, and we do the rest on Friday.
Exactly what I suggest.
Yeah.
So
if you go down to slide, not this, not that, not that. This one, hang on.
This one?
No, one up. This one here.
Okay.
So in the reference model, we are trying to sort of capture the entire story and pull it all together. And I think we are not completely consistent, coherent there yet. I think we are starting to get it on the mailing list, but the documents don't completely reflect that yet. So, okay, sorry.
Yeah.
Yeah, okay, that's better. So if you look at the currently drafts, it says in the ACP draft, we use insecure grasp, as Teles just explained. Brewski still only and exclusively refers to MDNS, right? So this is not in the document. Now, I looked at the discussion on the list, and specifically a mail from Michael put it together quite nicely. Discovery of the proxy by the pledge uses grasp mflood. Must for proxy, should for pledge, and MDNS should for proxy, may for pledge. I actually discussed with Michael just before this session, and you correct me if I get it wrong now, Michael, but I think what we are saying is the proxy must actively probe with grasp mflood. Yes? You're just kidding. Actively send out, okay? Whereas on the second line, it should accept, i.e. listen to MDNS. And that is not coming out. And for the scribe, can we write this down pretty literally so that we have this captured? So the grasp mflood is a must actively send out requirement for the proxy.
Michael, a quick correction. It's actually discovery. Discovery is flooding message have flood effect, but the flood is another separate message for different use. Right now it's a discovery message.
We want to use, Michael Richardson, we want to have mflood because we don't want the pledge to have to open a TCP port for the response and get many. Okay, so that's why mflood is the right answer here. And we also, I also think, and I think Michael's going to say something else about this, that we think that the mflood for ACP can be the same packet as for, it can also say whether the device is in fact willing to be a proxy or not at the same time.
Right.
So that I think makes it very nice and efficient.
Yeah, Brian? Yeah.
Yeah, I can you hear me?
Hear you, Brian. Yeah.
Can you hear me?
Hear you now. Yes.
Yes.
Okay, just there's a very long delay. So yes, I agree with Michael Richardson because because I'm sorry, I'm stuttering because of the echo. I agree with Michael Richardson because indeed both flood and discover messages are linked local multicasts, and the advantage of flood is that the only person who has to flood is the proxy. Or the ACP forming device, which could, as he said, be the same device. So there's no need for the pledge or the ACP joining device to broadcast their existence, which from a security point of view is better.
Thanks for that comment, Brian. And then looking at what's on this slide now, the slide is again incorrect because it should really say may for pledge. I think what we are saying is the proxy must send something actively. This is going to come in time periods of n seconds. We may want to have a model where the pledge actively starts the process, right? So it may start that. Would you agree? So it's probably not a should, it's a may.
Yes, I would.
Okay. And then, because then we are also getting closer to what I brought up a few days ago on the mailing list. To me, it would be really desirable to have one discovery protocol that is used for both. And Michael Richardson just pointed to that. We could now use the GRASP mFlood for both, right? So a node sends out, a proxy sends out GRASP mFlood for the Brewski method. And a node, once it has a certificate, once it has the LDEF ID, and it is, and it could establish ACP connections, it can then send an mFlood for I am an ACP node. Noting that in Brewski, we have a sort of a asymmetric relationship. There is the guy who is in the network, there's the new node, the pledge. In ACP, it's really a symmetric relationship. So it's not like one ACP node is above the other. They are the same. So both must send in that case. Now, where I'm still confused now is the MDNS thing. This will all be fine up to when we start MDNS again. So my question is, and that's a question for the Brewski team really, we wanted MDNS in there to support certain IoT profiles, I think, where we have sensors and stuff that do MDNS anyway. Should it now say, and that's the third bullet on this slide, depending on the context, if we use Brewski in an Anima context, we use the GRASP mFlood. Brewski could be used in a different context, in which case we could use MDNS.
We always use GRASP mFlood if there are any, if we always use a GRASP mFlood.
Why then MDNS?
Okay. So hang on, we always use it. So we always announce that it's always happening. If not, we get no ACP, we get no autonomic, we get nothing. Okay. For devices that are willing to be a proxy, they should respond to MDNS unless they have a good reason not to, like it's too much code or I don't know, whatever. And the reason is because the other device that's going to want to try to bootstrap, which is not really an Anima device, is not going to speak GRASP at all. Okay, but it's not going to do an ACP, it's not going to do anything else. And so this is simply that the autonomic network is providing the bootstrapping function for devices that are not going to be participating. Okay, and that's a little bit out of scope, okay, for us, but That's why that's the request is like, if this protocol is reusable by other things, then that's it. And this is how we make it reusable, is by putting the should on the proxy that says it would be nice if you supported this for this other use. It's a should. There's maybe very good reasons not to implement that code, but that's the process I would suggest.
Okay, so specifically, you are not suggesting the third bullet here that we separate per context. There is only one implementation, and it does what you.
The mandatory to implement for an Anima pure network is mFlood. Okay.
What does Brusky say, right? Because
Well,
Brusky
but the document. Let's discuss what the document should say, or must say.
no, but that's the issue.
Yeah, no, but that's the point. Is that's what I'm saying, that I think that the document will say is there. Now we've written other things. I think in part because until 2 weeks ago, the behavior of mFlood was, I would say, both unknown and unclear to us. We read mFlood and didn't understand what it was.
Okay.
And so we just went on reading and went, okay, I guess we need mDiscovery. We didn't like mDiscovery, so we went back to mDNS.
Okay.
Okay, that's it. So now that we have a better understanding of what mFlood is, and so that's a problem I have with the GRASP document that I haven't read all of 08 yet, so I don't know, it might be wonderful. But so that was the issue, is that it wasn't clear to us what this mFlood was for and how we would use it in this context. And I think it is clear that we should use it, and that's what we should be doing.
So for now, we agree the mFlooding is everything, we start. It starts from mFlood, and it found out whether we have the Anima context or not.
Right.
Yeah. Okay. Sounds
Well,
good.
hang on.
Yeah.
No, hang on.
Terence already online.
Okay, Phyllis.
Yeah, just wanted to quickly say, I think there was a lot more collaboration than people may remember, right? So was basically in the bootstrap, I think it was already in 07, either Max or somebody else wrote down the constraints against GRASP for the insecure discovery that would make the bootstrap team feel safe about it being secure enough. And that basically was taken by Brian to define the dull profile of GRASP. Now, I'm not sure if both texts are now 100% aligned, but I would suggest that the Bootstrap team goes back and revisits the, dull part of the GRASP draft and sees if there's anything, that doesn't suit them. Let's get that improved, and then maybe, on the Bootstrap draft, it can simply refer to dull GRASP version for the insecure discovery. That way we avoid having duplicate definitions and interpretations of the same thing.
Yeah, I think in the rush to October 31st draft documents, deadlines, I don't think that, I know I haven't read much of 08 yet, and I need to do that, and we probably need 2 weeks to revise the Brusky document to be consistent with it, such that we can, conclude the GRASP document and go on. That's, I don't think it'll take very much time. We just probably need the right amount of sleep first.
Yeah, that sounds like a plan. But so hang on, stay for a sec. So we are not doing this separation then in Brusky of this in case of Anima this, in case of non-Anima that. We just say what is under bullet 2 there. Is that?
Yeah, that's what I would like to say, and I would be perfectly happy, and I don't know if Max will agree with me, but I would be perfectly happy if there was a subsequent document elsewhere that said, and this is how you use Brusky to do non-Anima bootstrapping, and that would be out of scope for this working group.
Yeah.
Okay, and that would be perfectly acceptable, I think, to say, and you do this and this and this. Okay.
And then that document would have to say, if you use it outside Anima and MDNS is used, the should here must be a must.
Yes.
Yeah, actually, I'm fine if you guys want to include in such section in Anima Bootstrap document.
Okay.
Yeah, that's fine.
We could say something there. I think the reason why it may be better to say less is that it may be better to say fewer wrong things.
Yeah.
Right.
Maybe you can put that in appendix rather than the main text.
Okay, we can
Yeah.
put in a non-normative appendix. That would be fine.
Yeah. We start 3 minutes late, and we can end up 3 minutes late. But so for the last minutes, I would like to ask, what's the work plan for ACP document?
Can I just one final comment, just half a
Okay,
second?
go ahead.
The last bullet here. So I think the security issue is I think we are getting conclusions on that, but we should make sure that the security ADs are happy with that. Nancy, can you help us with that? Right, because we don't want to go down this track now and find in 2 months that there are still issues with it.
Okay, Kadis?
Yeah, I mean, I would love for people to chime in on the mailing list, or talk with Michael as the co-author in person, what they feel would be the open issues on the ACP draft that they would raise when we go to last call, so that we can basically clean them up front as soon as possible.
Yeah. Okay. Last question. What's the work plan for ACP? Do you expect you guys to make everything stable in 4 or 5 weeks? Is that reasonable to ask?
I think we are reasonably close to a consensus here. Yes, I think that should be feasible.
Okay.
Dennis, what do you think?
I agree.
Okay.
Okay.
I will be the document shepherd, so I'll do a detailed review in 3 weeks' time, I guess. Kadis, last word.
Yeah, well, I mean, Brian raised Brian raised the first point about the separation, so I'd let him chime in how important he sees, what text he might suggest. I was raising the bottom point. I hope I can find some time with Brian in email or so to make us feel safe that the number 2 use of GRASP and ACP can work.
Yeah. Okay. Well done. So see you guys on Friday. Thanks for your. Sorry about it, because we actually start 5 minutes late because the elevator. I was stuck for waiting the elevator. Next time we should really have check out the elevators when we choose a hotel.